guest.
This meeting is being recorded.
Because we are very pleased to have as our special guest today Professor Sören Auer, who is Professor of Data Science and Digital Libraries at Leibniz University Hanover. And he's also director of the TIB. TIB is Leibniz Information Center for Science and Technology University Library in Hanover since almost 10 years right now. He made very important contributions to the field of semantic technologies, knowledge engineering, and information systems, also by being a author and co-author of more than 200 peer-reviewed publications. He received several awards, including, for example, an ERC Consolidator grant. He also has led several large collaborative projects, such as the EU Horizon 2020 flagship project Big Data Europe. He also is a co-founder of quite many very important projects ongoing right now, like, for example, the Wikipedia semantification project, DBpedia, or the Open Research Knowledge Graph, which I believe will be one of the main topics for today. And without further ado, I would like to give the floor to Sören, and he will give a talk now on From Knowledge Graphs to AI Assistant, Transforming Scholarly Communication with ORKG and TIB Assistant.
Yeah, thank you very much, Anja. And let me share my slides as well. Actually, I will also have Allard, who you already know, on board. He will take over maybe for the second part and show you some updates about the AI assistant or KG Ask. But before we come to that, I want to maybe also introduce a little bit the vision, why we are working in this direction, what our bigger strategy is. Maybe there, the work we present is done at TIB, but it's completely open science, open source, open data, open in all different ways. And of course, we also are involved in this national research data initiatives, also in the European Open Science Cloud, by the way, and try to align this with these initiatives, in particular NFDI for engineering, NFDI for data science, or NFDI for energy, whose logos you can see here. Good. So to show you maybe a little bit TIB, who hasn't been in Hanover yet, you see TIB here in the foreground, the more modern building. In the background, you see the university, Leibniz University of Hanover. We actually are Leibniz Information Center, so you already see a lot of Leibniz, and this is not the only Leibniz library and not the only university with Leibniz in the name. We also have a Gottfried Wilhelm Leibniz library in Hanover, and we have a Leibniz Fachhochschule, like applied science university as well. Yeah, that's why I usually present a little bit how the relationship with all this Leibniz's is. So we are also library of the university with one smaller part, but the larger part is that we are a member of Leibniz Association and have this national role of being a national research infrastructure. Both have the namesake Gottfried Wilhelm Leibniz, and he was born in Leipzig, by the way, before he moved later to Hanover, where he died in 1716. And he's also the namesake of this famous Leibniz cookies. Yeah. And what you see here, this is already a knowledge graph, right? So, and organizing, disambiguating a little bit the knowledge, and that's what we work on a larger scale, of course, but introducing you a little bit how the setup is here. So, of course, many people now say, why don't we just use LLMs, right? And we can train larger models and add more content there. And to illustrate a little bit why this will not work or doesn't work, you can ask, for example, DeepSeek. It worked with ChatGPT. ChatGPT learned not to answer this question. But in DeepSeek, you can ask, what's the scandal with Professor Sören Auer? And you will get a long story about conflict of interest, data manipulation, misuse of research funds, double dipping on salaries and so on and so forth. Luckily, nothing of that is true. And this shows a little bit how LLMs work, right? So they work on statistical patterns, they detect scandal and professor, and there are a lot of, in the training data, you find a lot of information about scandals involving professors, where exactly this kind of things happen, then misuse of public funds, conflicts of interest, and so on and so forth. And that's then what is replicated by the LLM. And this, by the way, also ChatGPT or OpenAI does. They just learned not to answer such questions, but to follow a bit a different approach. Not to answer it from their neural network, basically, but doing a web search. So ChatGPT actually will search for Sören Auer and scandal on the web, will not find anything, and then answer, I didn't find anything on the web, so maybe there is no scandal. So it just learned not to answer certain questions in that way. Yeah, here actually is the version from ChatGPT, which worked in September 2025. Yeah, so not so long ago, and there was also a slightly different story, but also plagiarism, data manipulation, misappropriation of research funds. Quite entertaining to read. So, and this is a bit related, I would say, to this theory of Daniel Kahneman, who coined or developed, he got the Nobel Prize for his cognitive research. He analyzed actually how we humans think, and we have two ways of thinking. One is thinking fast and thinking slow. So thinking fast is intuitive, yeah, where we learned also from a lot of experiences, and then we can quickly react. But we also learn to think slow. So for very complex problems or certain problems, we understand that we should not maybe quickly react, but we should rather divide the problem into smaller subproblems, use tools, write some, I don't know, something down maybe, and solve a problem step by step. And that's this theory of Daniel Kahneman for human cognition, but I think it also applies to this generative AI models. Yeah. And that's why I would say that the generative AI models share a lot also with our human brain. So they have um, but they have similar deficiencies. And we actually also, as humans, we mix up things. We cannot memorize facts and dates very well. Those we have heard a lot, of course, we know, but many we also quickly forget again and mix up things and sometimes believe in false and misinformation and so on. But we also have learned to deal with these deficiencies of our brains. So we have peer review articles, books, we curate databases, we perform experiments, simulations. So we use a lot of external tools, a little bit other brains, and external tools to validate and scrutinize our knowledge and our findings. And I think we need to develop such an approach also in the world of generative AI. One approach to that is near-symbolic AI, where we basically put a knowledge graph between the generative AI models, the machine intelligence, and the human intelligence. And it has the advantage that this knowledge graph is something we humans can look at and we can understand and validate, scrutinize. But also, of course, the generative AI models can work with the knowledge graph, right? And create knowledge in the graph, and retrieve knowledge from the graph. And that's a little bit our vision to work in this direction, putting using a knowledge graph to represent knowledge, especially in science, but of course not ignoring the Gen AI and language model advances and using them to leverage the construction and creation of this knowledge graph. Actually, the language models and the knowledge graphs have very complementary features. So language models are very good at text processing, extraction, summarization, translation, generation of text, while knowledge graphs are good at knowledge representation and integration. The language models don't have a concept of facts. They still often get something right if it appears often enough in the training data. But in more sparse domains, they will not excel that much. Knowledge graphs, on the other hand, are human and machine readable. They can be scrutinized and validated. The language models or generative AI models are black boxes. They might contain hidden biases. They are often a bit superficial. The knowledge graphs, on the other hand, are very transparent. Also, the provenance can be traced. And computational, of course, there are also differences. We see that huge amounts, actually trillions of dollars, euros, are invested into building up data centers for these generative AI models. Knowledge graphs, I think, are a bit more modest in the requirements. And these complementarities, of course, result in very good integration opportunities. Yeah, so we can use knowledge graphs to represent a base of validated, trustworthy knowledge. They can help organize and integrate knowledge from different sources. Especially in science, we have a very heterogeneous with millions of researchers, hundred thousands of research groups, lots of universities, publishers, also, of course, non-profit organizations, research institutes, and so on. So very heterogeneous landscape. And that is something knowledge graphs are good at, representing information from various sources. And they can then also provide input for domain-specific training or fine-tuning. The language models, on the other hand, can help us curating the knowledge graphs. And I think the high learning curve for working with knowledge graphs, also with Sparkle, RDF schema, OWL, it's not rocket science, but still a bit complicated to learn. And that has slowed a bit the progress and penetration of knowledge graphs. There was, over the last 20 years, a lot of progress, but slow and steady, I would say. And now with language models, hopefully this can be accelerated a little bit because, many tasks can be performed also by LLMs there. For example, they can create mappings, queries for the knowledge graph, and can become something like a front end also for the interaction. And here's a bit how I see the vision maybe of how this development where LLMs appeared a few years ago, and they were initially used in isolation, and then these hallucinations were kicking in. They lacked this factual knowledge. That's why retrieval augmented generation was added. And I would say, meanwhile, most of the queries you do, or most of the interaction you do with a language model, for example, retrieves some additional information either from the web or from some documents which you upload. And that reduces then the hallucinations a lot. It's often mostly unstructured information, but the next step is that we also can use more structured information like knowledge graphs, databases, structured information sources. And another important step is this agentic generation, where we use tools, reasoners, APIs, computation services, and especially scientific workflows require that because we have like laboratory equipment and many different electronic lab notebooks. We have to write code, interpret data, and many other things there where these kind of tools can be very helpful or must be used. You cannot do science just with an LLM. It will be very superficial and a lot of hallucinations. That's why with agentic generation, however, I think we can mitigate some of these problems and really have AI assisting us in doing research. And maybe at some point there will be complete artificial general intelligence when we have the self-reflection goal setting also added there. But that's then a different and complicated, or will have a big impact also on the world, on the economy, societies. But maybe let's look a little bit also on this agentic AI. So agentic AI means that we have more autonomy, that we have more learning, adaptation, perception, decision making, interaction, communication, in these agentic systems. And when we look at these kind of workflows, we still can have natural language inputs, which is then interpreted and reasoned on, which generates a workflow, possibly, for example, scientific workflow, executes the workflow, but this can be then again, the results can be evaluated and we can have some kind of course correction and learning in the workflow execution through, for example, reinforcement learning, and finally come to an output. So it's a much more flexibilized workflows with a lot of more AI integrated into these different steps, which makes it also more creative maybe in the future, which we, I think, need to make new novel scientific discoveries. And that's also what we want to support. So this was maybe a little bit the general overview. Now, what about science? Yeah, so how does it look in science? And if we look a little bit at the last centuries, the representation of scientific knowledge has not changed that much. Yeah, the first proceedings or transactions of the Royal Society appeared in the 17th century, and the typography changed, but we still have static, relatively unstructured articles. We now have a lot of attention on research data, but I think still the most of the knowledge is represented in these papers, which makes it quite difficult to use and make sense of. There was Vannevar Bush, who shortly after World War II had this vision of developing something like a magical desk, Memex, which presents the information you need at your fingertips. I would say at that time it was pretty esoteric, but nowadays we are really able to realize that, and that's maybe something what we like a bit have in mind or inspires also our AI assistant. That still the researcher is in the steering at the steering wheel, right? So like in this memory extender concept, yeah, it's not replacing the human, but allowing the human to steer and to interact and get support by AI for the research. And one core concept we work on is organizing the scientific knowledge in a knowledge graph. So we want to organize overarching concepts like research problems, definitions, research approaches, methods, different kind of artifacts, in addition to publications, also data, software, and then also domain-specific concepts from the different scientific domains, like substances, structures, reactions in chemistry, or experiments, data, models, and physics in such a knowledge graph. So giving each one of these concepts an identity in the knowledge graph, and link and disambiguate the relationships between them, and of course use LLMs and generative AI to help us create this knowledge, extract it from papers, add it to the knowledge graph, maybe perform analysis on top, and so on and so forth. And that's what we implement with the open research knowledge graph. So we aim to be a bit the lighthouse in this flood of publications we are currently facing. Yeah, every year we have 7 million publications, I think, in science and technology alone. Overall, 250 million, maybe 300 million scientific publications out there. And it's harder and harder to make sense out of this flood. I think it will be even more accelerated with the rise of generative AI, which you can use, of course, also for writing and for drafting articles, and we want to canalize and organize and structure this a little bit more in the open research knowledge graph. And maybe I show you some live information, but I think I have to switch to the to my web browser. So 1 second. So now you should see my browser. So that's how the Open Research Knowledge Graph looks like, right? And you can go into different fields of science here. For example, engineering, and then you have subfields there in engineering. But what we have there is not papers, but we have comparisons of the state of the art. Yeah. So and you see here quite a number of different comparisons. For example, here are these studies on Germany's energy supply in 2050. So this is something we developed together with NFDI for ING, but also NFDI for engineering and for energy. And it's part of an observatory on energy systems research. So we want to transform um, um, our energy supply to make it completely renewable in 2050. And there are different studies how we can achieve that. We actually have here 25 of these studies, and each one has different assumptions, different predictions, different conclusions. And in order to get an overview, you had to read either these 25 studies. Each one is like 15, 20, 30 pages, right? So you have quickly 500 pages of paper. And here in the Open Research Knowledge Graph, we represent the information from these studies in a more structured way. And that's what's shown here below. So each of the studies is a column in this overview, in this comparison here. And then we have in the rows, we have different properties. For example, the energy sources which are considered. So the studies here consider all sources, but then also the electricity generation, which is assumed, the installed capacity for renewable energy, and you can then compare this according to the different studies. Yeah, here we have different energy sources like bioenergy, and then the electricity generation, geothermic. So for each of the different energy sources, some energy is also imported from other countries and so on. It's described what kind of capacity is assumed there. And then there are different scenarios like 100% CO2 reduction till 2050 here. And you can see that this is, on the one hand, we have a human readable version, but we also have represented in a machine readable way that we have here this value of 100, but also then the unit percent and the type CO2 reduction and the time frame till 2050. So it's a structured semantic representation. It looks a little bit like an Excel table, but it is actually a much deeper semantic structure. So it's really a knowledge graph, and you see that when you mouse over these kind of resources, you see the identifiers. You also here on the left-hand side see that there is some hierarchy in the properties, right? So it's indeed a graph behind it. We actually can also look at the graph. So when you go here, view graph, then it will show you the graph as well. And you can already see it's relatively cumbersome maybe to make sense in the graph. That's why we don't show the graph immediately, but rather these kind of comparisons, tabular comparisons, because they are a little bit easier to work with. And you can zoom in here and you have all the different nodes and the representation of the graph basically visible here. The metadata, but also the representation really of the content from the studies. And that's a bit the difference to other most of the other knowledge graphs, that they are mostly more focusing on. We really focused right within the papers. Actually, the metadata we retrieve from Crossref or from other sources. And since we have this machine readable representation here in this graph, you see the 25 different studies here in the columns. We are also able, then you can query that, and you can, for example, create a different kind of visualizations. Like here we have a bar chart indicating the installed capacity of the different renewable energy sources according to these different studies. Yeah, what needs to be installed. And then this can be used, for example, by politicians to decide um, up renewable energy in Germany till 2050. And that gives you a much more transparent overview. But you also can launch here a Jupyter notebook, for example. It actually opens from Genesis, um, the MyBinder version from Genesis then, and loads the data frame right away with all the data. I stopped this now here. And many other things. You can export a LaTeX, for example, of this table. You can integrate it in your paper directly. So you have also all the BibTeX references included there. You can export as PDF, as RDF. The citations can be exported. You can see the history, who has changed what here, because it works a little bit like a wiki. Everybody can contribute and edit. For example, when you click here on the edit button, you are actually also able then to edit certain information here. So we go to one of the studies, and when I click on the edit button, it basically loads an editor. I have the possibility to delete things, to edit things, but I can also see here on the right-hand side who has edited what at what point in time. Yeah, you can add new properties. You can also generate suggestions from a generative AI model here. We have templates and many other things in the Open Research Knowledge Graph. Yeah. So in addition to these comparisons, of course, we also have different other ways you can integrate them into reviews. For example, here we have reviews this is something a colleague from Cameroon has done, Fidel Geomekong, which is also contributing to a certain societal challenges defined by the United Nations here. And then this is a whole article which is created using the structured content. So you can embed these kind of comparisons directly inside an article. And we also now launch a journal for these kind of articles which are contain such structured content from the Open Research Knowledge Graph. Yeah, we also have like maybe one more thing I can show you is the benchmarks, and then I will hand over to Allard. For benchmarks, this is something which is quite important in computer science, but also I could imagine similar things could be applied maybe in material science and other areas. So we have different benchmarks for research approaches here. For example, image classification is a research problem. And then for this research problem, we have different benchmarks here. For example, ImageNet is a popular one. And once we select the benchmark, it loads then the papers which use this benchmark and perform certain problems. For example, here image classification, you see a number of different problems: density estimation, color image denoising, and so on and so forth. Here's in that case, a long list of research problems. And then you can retrieve here also the top 5 accuracy, for example. And then you see a little bit how the performance over time improved, hopefully, and how these different research approaches scored according to this particular metric, right? But and you can switch the metrics, but maybe also the scalability of the approaches is important, right? So like the higher ones here seem to be quite fast since they do a lot of operations, and it gives you a lot of possibilities to analyze the data according to different dimensions. But in the end, it's the same representation. We have the papers here. When you go to the paper, it looks exactly the same as previously. Of course, completely different topic. It's not energy studies. Now it's here about algorithms for image analytics, image processing, right? But we also have again a graph with properties and values and represented information about the performance of these algorithms. And here you see also the links to other artifacts like GitHub with the implementations for the code discussed in this particular paper. And that is something we imported from papers with code. And these are just some examples. There are many more examples. We actually also want to support. We have an API. You can also like look at the statistics, how many statements, how many papers, how many comparisons we have, and so on. We are very transparent with how many users with all of this. And you can also here with data access, for example, use the REST API, Sparkle endpoint. You can download the RDF dump, use Python to use the ORKG API, and develop basically also your own user interfaces. And there are already some examples there as well of user interfaces built on top of the Open Research Knowledge Graph. Good. With this, I will maybe end my part and then hand over to Allard. And Allard, feel free to add also something related to the Open Research Knowledge Graph. And then Allard has also some updates related to the AI assistant and ORKG Ask since his last presentation, I think October last year.
Yes, exactly. Thank you. So I will share my screen. And then continue a bit first with the ORKG, actually, some updates there, then with Ask, and then the TIB assistance. So for the ORKG, so I'm really trying to go through some of the upcoming things, right? So the things that we are currently working on, and then specifically on how we are trying to integrate AI into these different services, and also why we are doing that. So specifically for the ORKG, Sören just already showed this feature where sometimes you have a light bulb icon in the interface, and you can click this, and this is basically when AI or specifically LLMs are invoked to basically help the user to come up with better statements or with suitable properties and so on. So we did this in many places in the UI, and that's because always at the key of the ORKG has been the manual curation. So the users always should manually curate data. In the past, this was really like manually creating as well. But now with AI assistance and then even the next step, AI collaboration, it's more going to be a matter of validating instead of just doing everything from scratch. So the AI assistance tools, as you see them here, so for example, this pop-up, right, where we get suggestions, they are now in the ORKG for some time already. But what we are doing now is really working on the next steps. And one of those next steps, specifically to what Sören just showed for the comparisons, is that AI is trying to generate the majority of the comparison already, and then the user is in charge of verifying this. This is the page where you normally would create a comparison. So you would start with entering a title and then click create. But our update would include a button where the user can click on and then automatically create a comparison based on a set of papers they supply. So basically the papers are then parsed, and then this text is being analyzed to come up with a suitable structure. And that is then entered in a initial version of a comparison. This is then how that could look like, right? So in this case, I would have entered some papers. You'll see some data that is displayed here, like in a similar view as the comparisons you just saw. The only difference is now that we see these exclamation marks. And these are then the points where basically the user is being asked, okay, please verify this before you are continuing with this comparison. So this is a so-called draft. So others don't necessarily see this. Only after the user has verified everything, this comparison can be published. So for example, when clicking on a certain button here, The user gets context, like where it's coming from, maybe what's the confidence level of the AI model that was being used, and trying to give as much context as possible so the user can make an informed decision on whether this is correct or not. And we really envision this approach a bit as the next step for the ORKG, where we were always focusing a lot on manual curation, but now it's going to go much more also into validation. So AI can do a lot of the work, and then the humans validate whether that is correct or not. This is not yet available online. That's why I'm showing it in screenshots here, but this is something that we're working on. So that was it for the ORKG comparison specifically. Then we also have the ORKG Ask service. So last time during this the same series, right? So I presented a bit an introduction and what we are doing in Ask and so on. And let's not do that again, but just for those that were not there. So ORKG Ask is a service where researchers can ask research questions in natural language, and then they get basically a list of articles back, and we try to answer those questions based on the presented articles. And what we have always been doing is use our locally hosted models. So in this case, specifically, we are using Mistral 7B, which is an open weight model, and that has some benefits, right? So because it's open weight and local, it's privacy friendly. The data stays within our institute. We are not invoking any external services. And so far, the performance is quite well, specifically in English. So the service is being used by many users on a daily basis. But we also would like to take Ask to the next level. And to do that, we come to the realization that smaller models, although they have many benefits, of course, also have some challenges or some downsides. And one of that is that adding features to the system becomes rather cumbersome. If you have a small model with a very detailed prompt, changing this prompt could actually result in certain features not working anymore because the prompt produces basically different output because of the changes in the prompts. So this is something like considered, or it can be called as prompt sensitivity, right? So small changes in the prompt could completely change the outputs. Also, we looked at fine-tuning to improve the performance of the model, but then you're also losing some flexibility, right? So when a model is fine-tuned and you would like to add a feature, for example, we say, okay, we want to change the tone of the model, we would have to do the fine-tuning again and create data sets again for that. So while fine-tuning is an option, it is not necessarily the first thing that we are looking at right now. So what we are considering is, okay, what if we, in addition to our local models, also add larger models to the system? So for us, there are some benefits. So we would increase development speed of features because these models are capable in supporting those features without too much prompt engineering. And that means that we will be able to add several features that specifically were requested by users in the past relatively quickly. I think even during this meeting, we had some questions about this, like how can we do certain things like source extraction and knowing where data comes from. And this becomes easier when we are using bigger models. Why then not just always use bigger models, right? Well, the very large models, they are just difficult to host locally or you need a lot of resources. When not used locally, of course, there's always the issues of privacy. You send something to an external service, what happens with your data and so on. And of course, just in general, the reliance on those services. And of course, in addition to that, you pay per token as well when using cloud services. So since both approaches, the smaller models and the bigger models have their own pros and cons, what we are considering now is to add a model selection in Ask. So we will not remove anything that we have currently. So we will keep our local model, but we're also planning to add other larger models there. And then basically we can provide this to the user. So we can tell the user, okay, it's up to you. You can decide whether you want to use our model. In this case, you see a small comparison of this model, right? So you see where the model is hosted, also in which country, what features it supports, and how much you can use this as a user. And then our standard model, Mistral 7B, compared to, for example, a paid model, we can see the location is different, but it supports some more features. On the other hand, there is a token limit per day, and this is not open source. And this is sort of our plan forward to support these additional features, to first add them to the bigger models, to basically to being able to present and release features more quickly. And then once they are out, trying to also, of course, port them to our smaller, maybe fine-tuned models as well. But at least we are not blocked, so to say, by these smaller models. And some of the new features you can think of, one of the things I just mentioned is the source display, right? So we could, for example, in ask, see, okay, if an answer is generated, so we ask our question, we get our answer back, where does this answer comes from in the text? So we already know which paper it comes from, but now we can see the actual sentences where it comes from. Also, we are able to more structuredly extract knowledge. So currently it's always based on natural text, but in case we are interested in the scale of an evaluation, as an example, we can provide instructions to the model what we exactly want, and then we can say, okay, our range of answers should only include large or medium and small. So then the model knows, okay, I have to choose between those options. And this works quite well with larger models. Very simple tasks, such as trying to guide the user more in the UI. So this is really user experience features where you say, okay, somebody is asking a question, but we know Ask is not able to answer this question. We will present that to the user. So we will analyze the question and then say, okay, one of the requirements in Ask is that you have to really ask a research question. And if you, for example, instruct it like you would do with generic LLMs, like return some questions or return something, that won't work well because it's really question-based. And that's what we can do now. We can analyze the question and then inform the user that it's invalid. If you hover over this, you will see some instructions on how to rephrase it to make it a proper question. Also, we will have more powerful synthesis because the context window grows, right? So we're able to analyze more papers at the same time. And finally, we can even think about questions such as paper chat and so on, where you can really interact with a paper, and that we're not only using the knowledge basically from the paper, but we can even use the parametric knowledge of the model, so it's able to reason more about the results that are displayed. So that's up for Ask. So this is something that we are currently working on, trying to integrate these bigger models and see what features we can support there. And then finally, some quick updates about the TIB assistant. So this is also something presented last time, right, where I talked about how we're trying to build a research assistant that helps researchers throughout the research lifecycle. I believe also I showed a quick demo of how this works and how you can interact with the system. But we are currently working on some features to make the organization of information easier within the system, and therefore making it easier for people to add assistants and to add tools to the system. So it's really going to be a platform where multiple researchers or multiple institutes can work together to deploy their AI approaches. So here on the left, we can see all our different research assistants or our different agents. So they are responsible for specific research tasks. At the bottom, we have our chat window and the ability to select tools. So we can say, okay, you have access to external web services, for example, and then the generated assets. So what is being generated, and that can be then moved to other assistants as well. So looking at the assistants, so we are working on an assistant lifecycle library where you can really see, okay, we have many different assistants in the system. People can add them without basically discussing with us whether it makes sense or not, because they can just add them to the library. If people want to use them, that is fine. And if not, that's also fine. And then we have different features in here, right? So we can select a life cycle. We have a library of life cycles as well. So they consists of individual assistants. Then we have detailed information about assistants, metadata, and of course, search and filtering to make it possible for people to find them in the large number of assistants that we are hopefully having in the future. Here we can then select our pipelines, as I mentioned, right? So they are also predefined and work in a similar fashion. So also in a library sort of setup. And here we have then the detailed information of individual assistants. Finally, we are doing the same for tools. So also there, in the past, we integrated external tools within the system. So we supported Crossref, Semantic Scholar, and so on. Now we are basically moving all those tools out to external MCP servers, and that gives the benefit a bit that others are able to just plug in their external MCP servers and then use them directly in the TIB assistant. So this doesn't require any coding or integration from the user. It's really just a matter of, okay, you can click a button here at your MCP server and directly start using that in the TIB assistant. And that's also really one of the main parts then of the TIB assistant, where we're saying, okay, we're really building this library now. It's all a matter of plugging in components, being very flexible, because different researchers use different workflows, different domains require different workflows. So this is all about making the platform as flexible as possible and to support all those different use cases that maybe even we ourselves haven't thought about yet, but others want to execute within the platform. That's it from my side as well then. I'll stop sharing my screen. Thank you very much. And I think there's some time for questions as well, right?
Yeah, we do have some time left. So thank you very much to both of you, to Sören and to Auer. That was really a great overview of what you're doing now and a lot of updates since I've met you the last time. So very happy to see that you're moving forward. And indeed, we have no time for questions.